Chapter 7 is all about radicals, but we won't be dealing with just square roots. We'll have cube roots and fourth roots and beyond also. So we need to really have a good understanding of what's going on. First off, the square root of 25 is equal to 5 since 5 squared is equal to 25. Now the question that follows from this is, can the square root of 25 equal to negative 5 since negative 5 will square it to be positive 25? And the answer is no. Only positives can come out or can result from a square root. Now, let's think about this for a little bit. Some books are going to say that we have a principal square root, which is 5, and a secondary square root, but we're not going to go with that definition. We're going to just say the square root of a number must be positive. And that will not only be true for square roots, but fourth roots and sixth roots, or any even type of root, eventh root that we can deal with. The next question comes, what is the square root of negative 25? And the answer is, this is not possible using real numbers. Now, when we get to imaginary numbers later on in this chapter, then it will be acceptable to take the square root of negative 25. But there is no number which multiplied by itself gives negative 25 using the real number system. Now, can we have an answer to a square root that's negative? The answer is yes, and that we see in this next problem, because this is a negative 1 times the square root of 25, which gives us negative 5. The negative is not the answer of the square root. 25 square roots to 5, and the negative gets attached later. Now, something to mention about square roots. There's an understood little 2 right there, and that position is called the index of the radical that tells you that it's a square root. We do not write the 2 there because most roots are square roots, and it's like a 1 in front of an x. We don't want to write that 1 all the time. But when we move on to this next problem, which is a cube root, we do need to have that 3 written there. And the answer to this is going to equal negative 2, since negative 2, when you cube it, is equal to negative 8. So what are we learning? We're learning that we're allowed to have a negative inside of a cube root, or when the index is odd, but we're not allowed to have a negative inside of a radical when the index is even. Now for this next problem, you may say, okay, squaring and square rooting are opposite processes, so my answer should be negative 8. Well, that's not true. The answer is actually positive 8 here. And we can think of this in a couple of different ways. One way is we can think of this as the square root of 64, which you know is going to be 8. You could also say, hey, the answer must always be positive, and just say, hey, by definition it's going to be. Or you can put absolute values around that negative 8 and say the answer is 8 that way. Squaring and square rooting are not exactly opposites of each other because of this plus or minus type of issue and absolute values that we've got to deal with. In general, anytime you are taking the square root of x squared, the answer is not x. The answer is the absolute value of x, because whatever comes out of this even indeced radical must be a positive value. Now let's use these properties to move a little bit forward. What's the square root of 100? Answer, 10. What's the square root of 144x squared? Well, you want to say 12x, but you don't know whether x is positive or not, so we have to force the absolute values around that x so that our answer is positive. Now on the next problem, the square root of 225 is 15. And the square root of w squared is, or w fourth, is w squared. We don't need absolute values around the w squared because it's assumed to be positive anyways. Now let's look at that w to the fourth. Why do we have that? Well, w to the fourth is w times w times w times w, and the square root undoes squares. So there's a w squared, there is another w squared, bringing out a w and a w, making w squared. The next problem here is going to equal 13w to the third. Notice I'm just cutting the exponent in half for each variable. This has an odd exponent, so we do need to have absolute values. And for this next problem after it, the index is even, and so when we go 4 divided by 4 and get x, we don't know if that answer is positive or not. We do need to have absolute values. Now, I do need to put a disclaimer on here. I'm mentioning these absolute values right now, and we do need to pay attention to them, but quite often we have in the directions something that says assume all variables represent positive values. Now, if you see that in the directions, that pretty much tells you, hey, you don't have to worry about absolute values on this problem, and you're kind of free to go without them. But if that is not listed in the directions, then you need to put these absolute values on where they are necessary. Now, when specifically do you need absolute values? Well, first off, when odd exponents on the outside, so I'm going to say come out of an even indiced radical. Now, indiced is just the way we write indexed, but that's a more professional way of writing that. Radicals. So let's look at these very carefully. In the last few examples, I had w squared coming out. That is not an odd exponent. Anything raised to an even power we know is positive. But x to the first and x to the third are odd exponents, both coming out of even indiced radicals. When we have a cube root, just automatically when the index is odd, we don't even pay attention to absolute values because we're allowed to have negatives both inside and outside of a cube root. Let's continue on. The fifth root of 32 is equal to 2. Now, if you need to do a factor tree on 32 and say, 32 is 8 times 4, 8 is 4 times 2, and a 4 is another 2 times 2, and here's a 2 times 2, bring all these down, and it's a 5 of a kind, a fifth root we're looking for. There's my 2 as an answer. Go for it, but you'll start to learn many of these values as you start to do a lot of these problems. The cube root of 27 is equal to 3. The cube root of negative 27 is equal to negative 3. The fifth root of a to the fifth is equal to a, and no absolute values are needed on this variable because the index is odd and a can be positive or negative as it needs to be. The fifth root of 32, we know that that is going to equal 2. The fifth root of x to the fifth will be x. And the fifth root of y to the 10th will be y squared. Notice how I can just go 5 to the power divided by 5. The index gives me an outside value of 1, and 10 divided by 5 is 2. That works. And I do not need to consider absolute values here because this was an odd indiced radical. Now let's find the domain and use interval notation. This should be repeat material for you. For this square root, we have an x minus 3 underneath the radical, so x minus 3 must be greater than or equal to 0. Therefore, x must be greater than or equal to 3, and the domain will be from 3, which we include, on up to infinity. Likewise, on the next problem, which is also an even indiced radical, I can write 5 minus 3x must be greater than or equal to 0. I can subtract 5 on each side and get a negative 5, but be careful, whenever you divide by a negative, you change the direction of the inequality, and so here we're going to have the values starting at negative infinity and going up to and including the 5/3. For problem number 13, automatically the answer is all real numbers. No thoughts about it because the index is odd and we're allowed to have negatives and positives both inside of our radical, and so there are no restrictions.